Because he's sick.
It's so nice of him to not kill us.
Yay.
Consider it, yeah. That's
So how do we know this is a monotonic? We can actually using Calc 1. And since we know n is always greater than 1, greater equal to 1, you're a to the n. So in order to do monotonic in this particular case, we want to see using Calc 1, which is just take a derivative, which is f of x is equal to x e to the x. And if I take a derivative of this, it's going to be low d high minus high d low over low low. So e to the x can factor out 1 minus x over e to the x times e to the x. And Will asked a good question earlier. Said if I did number line test e to the x 1 minus x at 1, this is a positive because anything I plug in is positive. If here I'm going to plug in, I'm going to get positive, I'm going to plug in negative. So this is going to be increasing, decreasing. You say that's not monotonic, but it's not true because I only care from 1 and up. Because remember, n is always greater than 1, and that's how sequence work. Sequence work is going to be work on first term. You're not going to get negative 1 term or a 0 term. You're going to get first term. At a minimum, you start at the first term. Does that make sense, this part? Okay, so that we say this is a monotonic because from here going down is decreasing, and which is good. And we also talk about this. Sorry, let me going to redo this one. I do apologize. I want to record for somebody who's going to be gone for a week. So we are compared to the a to the n is less than no, actually a to the n is greater than a to the n plus 1. So this is how do you prove decreasing? Does this make sense? If this is true, if true, then the an is monotonic decreasing. Decreasing. Okay, so now I can also prove another statement. So an plus 1 is greater than 1. Long as you can prove this, I can see if they are monotonic. Then what I'm going to do is I'm going to do compare 2 to the n over n factorial is greater than 2 to the n plus 1 over n plus 1 factorial. Now I'm going to divide it by both sides just because I can compare to 1 pretty easily. Okay. And this is good for Emily because Emily still zoning now. You were? Okay. Divided by 2 to the n plus 1 over n plus 1 factorial. If I divide both sides, that's greater than 1. Since this fraction divided by this fraction, I can do, hopefully you guys finish working because you should finish working like this.
I thought we could do it together.
You can probably figure out by yourself. So this is going to be n plus 1 factorial. You have all this time. And 2 to the n plus 1 is greater than 1. Don't wait for me. So I'm going to break up to the 2n and 2n plus 1. So I'm going to re-switch the positions. And not only that, 2n plus 1, I'm going to change to 2n times 2. Is that okay? And then times...
You can do that?
Yes, you can do that. X to the a times x to the b equal to x to the a plus b.
We do something like that with like c, right? Yeah.
So in here it's going to be m plus 1. No, I'm going to change that n plus 1 factorial. I'm going to change n plus 1 times n factorial over n factorial. Do you see what I did?
Yes.
So that's greater than 1. So nice thing is this. Beautiful. Beautiful. It's m plus 1 over 2 is always greater than 1. Is this true?
Yes.
True. Therefore, is monotonic, decreasing. So because at first, if you plug in 1, it's going to be 1 greater than 1, which is still true. And if you plug in 2, what would you get? 2 plus 1 over 2 is greater than 1, which is also true. Right? And it doesn't matter what value you plug in after that, it's always true. Therefore, it's strictly decreasing. Are we okay here?
Yes.
Excellent. So this, I don't know if I can provide any question because this example, I got it from a professor. And I thought like he does a very good job on explaining things. So I thought like he did this part really well to show you guys if you know a function's monotonic. Now we would like to go to series. So what's the difference between sequence versus a series? Can you tell me what a series mean?
Say.
A series is a bunch of
I only know
numbers that are in order to do a bunch of outputs.
It's like Donald Trump is saying teaching series and series sequence.
No, he has to do the voice though.
Now what is series
It's
then?
like you know like when you're playing cards, right? It's like a flush versus a straight.
Yeah.
You know what I'm saying?
I'm trying to make it a connection, but no. Sequence. Okay, so let's just give you an example. A sequence, if you learn algebra 2, I'm going to give you a quick breakdown of algebra 2. Is that okay? Algebra 2, they were arithmetic. Arithmetic sequence. Do you remember that?
Oh, and then multiplication is series?
That's like a 5, 9, 13, 17. Why?
What's he doing, guys? +4. +4.
It's a +4 each time, right? So you plus a number or you subtract a number, that's called arithmetic sequence. Got it?
Got it.
Okay, I'm going to give you a quick breakdown.
Geometric series. Oh my gosh.
What's an arithmetic sequence? A series, sorry, series. What's the difference between sequence and series? Well, series is going to be 5 plus 9 plus 13 plus 17. So what's the difference between sequence and series?
Yes.
They're adding. And you're going to be like, Mr. Yeah, if you're adding this, it's just going to go to infinity. Well, it's true. It's true. This will always usually get to infinity or negative infinity if they are arithmetic series. However, there is another type of sequence. It's called geometric sequence. Okay, so geometric sequence looks like this. 2, -4, 8, -16. You're gonna say, why this geometric sequence? Okay, so there's a difference between arithmetic and geometric. So arithmetic, the word arithmetic is gonna have a common, I'm gonna write it in red. It's called common difference. I'm gonna give you like a fast algebra 2 breakdown. Common difference.
Because they're always the same difference if you take 1 and minus the previous.
Good. Actually, this come into a very, very cool question I will show you later. It's one of the students I tutored yesterday showed me this geometric sequence. I was like, what the hell is this? And he's like, finding K. I was like, what the hell is this? But that's an interesting question. Common difference. That means if you do a to the 2 minus a to 1, can you guys look at the thing? A to the 3 minus a to the 2. It's same thing of your second term. Here, give it to me. The second term minus first term is always going to be the same thing as a to the third minus second term. Is that okay? Okay, so what is the difference between geometric sequence? Geometric sequence has a common what?
Yeah. Common factor.
Common difference.
Common factor.
Common difference. Oh wait, no, that's a fact.
Show the R.
Reciprocal.
Ratios.
Oh.
Okay, so this one has a common ratio. So what is common ratio? For example, your second term divided by first term is always equate to the third term divided by second term. It's always equate to A4 divided by A what? 3. So they're always the same. See -4 divided by 2? -2. 8 divided by -4? -2. -16 divided by 8? -2. Wow, magic. So there's a common ratio. And this is how you get common ratio. Are we okay here? And you're going to be like, there's one more thing. Of course, there's a geometric.
I remember I don't like this. This is in the competition stuff we do.
Yeah, geometric series, it's going to be 2 minus 4 plus 8 minus 16, dot, 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 dot. And you're going to be like, let's see it. This is going to be diverged. Duh. If it goes infinite, the number is going to get either very positive or very negative, right?
Unless.
Yes. Okay, so, and it's also going to be oscillating. And that's for sure, it's going to be diverged. Because you look at first term, it's positive. You look at second term, it's going to be negative. You look at third term, it's going to be positive. You can look at fourth term, it's going to be negative. You swap between positive and negative, positive, negative, positive, negative. Guess what? This is diverge. It's any kind of series that's converged, though. How is it a series? It's become converged. We're going to study this tomorrow, but we're going to talk about it today. What do you think the ratio need to be? Yes. The ratio has to be less than 1 to be converge. It's actually the absolute value of the ratio has to be less than 1. Why you pack things up? What's going on there? If something I don't know about.
I honestly checked the time when you said, oh, we're going to talk about this tomorrow. I was like,
Oh.
Yeah.
that was the word. That was a trigger word.
Yeah.
We're gonna talk about it tomorrow. I'll pack the things up. I'll see you tomorrow. Okay, so if the common ratio is less than 1, why is absolute value? Absolute value could be, the R could be negative as well. It could be positive, but longer as they're less than 1. So negative 0.8, negative 0.5, 0.8, 0.5. The common ratio is going to give you that. Okay, so let's talk about infinite series now.
It can't be equal to 1?
No, only less than 1.
Okay.
Infinite series. That's a good question, by the way. I'm always address what is good questions. So
Yeah.
I'm going to show you what does the infinite series look like anyway. So this is what the infinite series look like. N equal to 1 is infinite, and this is a to the n is equal to a1 plus a2 plus a3 plus a dot dot dot
4. Oh.
a to the n, and then plus even term after that. There's after terms after an plus 1, an plus 2. It just keep on adding, right? And you say, oh, okay, that's very easy. So if I have S1, that just means A1. If I have S2, that means A1 plus A2. If I have S3, that means A1 plus A2 plus A3. You got a point. That's called a partial sum.
Or are you talking about S? Like, are you just defining them?
Yeah, we're just defining. So if I say series, then that's series 1. Then that's going to be series sub 1. Then it's going to be A sub 1. Series sub 2 is going to be A sub 1 plus A sub 2. Am I going too fast?
No.
Or am I not going fast enough?
No. You're going good speed.
Equal to 1. Infinity A to the n. So the nth term partial sum, we got a new word, the nth term partial sum. Okay, I'm sure this is red as well. Style red. That's what's nice about iPad.
The two partial sum
Yeah, nth term partial sum. So Sn is equal to A1 plus A2 plus A3, but this one is going to stop at An. So this is called a partial sum. So if I say S to the 6, just going to be A1 plus A2 plus A3 plus A3, but paste A4, A5, A6, and keep on adding. So that's called partial sum. Now, we're going to give you a statement here. This is according to the definition. They say if the sequence partial sum,
Oh, it's not here. Oh,
What is that?
Oh. It always used to be.
what are you looking for?
Do you give me a square?
Everybody gets a square.
Oh, ew.
If the sequence of the partial sum s to the n, it converge to s.
thanks, there.
Okay, so if it converge to s, then the series n equal to 1, infinity a to the n, it converge.
That's a bunch of words right there.
Then, Allah, sorry, I'm just copying exact word from the book because I don't know how to write this in correct sentence. The limit s is called sum of the series. Sum of the series. So s is equal to a1 plus a2 plus a3 plus a to the n plus keep on going. So s is basically the sum of everything, the infinite series. Now if s to the n diverges, then the series diverge.
Question.
Yes.
You just said if the sequence, a partial sum converges to S, then the series converges?
Yes.
Okay.
If the partial sum converge to s, then the infinite series is converges. If the limit of the s is called sum of the series, if you sum everything, and if it's diverge, that means it's going to go to infinite or go to oscillation. That's definitely diverge. If it goes to a specific number, then it's converge. Okay, we're going to talk about one thing. Can you tell me if this is converge or diverge? Now, remember, this is a series, not sequence. There's a big difference between sequence and series. This is a series because it has a summation mark. And that is the sequence 1 over 2n.
Divergence. No.
It's constantly adding, but it's like converges, right?
Yeah, because it's eventually going to start
Does
adding
it
like
converge
so
at one?
small that it's going to be like.
At a certain point, like the wall, right?
Because the limit is infinity.
No,
When you get to infinity, you stop adding.
Well, let me go.
1 over 2 plus 1 over 4 plus 1 over 8.
Yeah,
Yeah,
converge
yeah,
that one. It's the
It definitely converges. So just show us the example of 1 over 2 plus 1 over 3 plus 1
We
over
were adding 1 over 2.
And that one
plus
diverges.
1 over 8 plus 1 over 6.
1 over 2 and then
32. So it's gonna-
Yeah. So think of a pizza, right? You have a 1 over 2, just like you have the first day, I'll give you 1 pizza. And the first day, you're going to eat half the pizza. And the second day, you're going to eat 1/4 the pizza. And Robert will eat all, yes. 1 over 8 and 1 over 16. Now, eventually, we don't know what is it, so I'm going to show you what a formation, okay? S1 is equal to 1/2. Does that make sense? S2 is equal to 1/2 plus 1/4. That's equal to what? 3, 4. Good. S to the third is equal to 1/2 plus 1/4 plus 1/8 is what?
Yes.
4/8.
No, you dumb.
7/8.
7/8. You finally learn how to count after
Yeah.
30 seconds, right?
And I bet the next one is gonna be 15/16.
Ah, now you see the pattern. Now, can you write this in a general term? S to the n.
-1/n.
No, you dumb.
Dang.
It's the base plus the
If it's n, if this one is 3, how come this is 8?
It's
oh.
the power of 3, so it's n to the power of n. No, 2 to the power of n. That's what I said.
It's like you're adding the denominator to the numerator.
Can you write an expression that represents all the partial sum?
Wouldn't that be 8 to the n though?
Look at the pattern. Don't just say no. 1/2, 3/4, 7/8. You already predicted 15/16.
Oh.
Yes, it will.
Wait. Oh, wait. It's like 2n plus 1 over 2n, right?
Almost had it right.
No?
You almost had it right. You just had one wrong sign.
Over n squared.
Over n.
No, sorry.
2 to the n minus 1.
Oh, okay.
Wouldn't that be 8 to the n though? Because if you did s to the n, you'd be adding
Or
that
s
to
to
some
the-
continuously, right?
Yeah, we're talking about this. This is the pattern for the partial sum right now.
Okay.
So this is a partial sum. This is a general term of partial sum. Guess what? If I ever says, hey, what is S? What does that mean?
You divide everything by s.
It's infinite.
No, S is gonna be infinite. So it will be this partial sum is gonna be the infinite sum is gonna be limits as n approach infinity of 2n minus 1 over 2n. And if you do this, because this gonna give you exact result of the series, right? So if it goes to infinite, what will happen? Will be, well, if I go into that, it's an infinity over infinity, so I'm going to take a derivative, so it'll be natural log of 2 to the 2 to the n over natural log of 2 to the 2 to the n. So that's equal to 1, just like what you're saying. Derivative 1 is 0, so that's equal to 1. So eventually that series is equal to 1, just like what we predicted with the half pizza situation.
Well, what did you just do?
I take a L-Hopper rule.
Oh, okay.
Do the dividing by the greatest power thing, like can you-
There is no greatest power here. It's 2 to the n.
You can't really.
So
you
it's
can't divide
Not
by
x
three.
squared. X squared, then you can divide it by half.
wait.
You do L-Hopper rule.
How do you do the hospital rule of 2 to the n? How do you derive it 2 to the n?
Ah.
It's like power rule. So it's
Y equal to 2 to the x.
It's ln.
Ln of y equal to x ln of 2.
Yeah.
Take a derivative. Y prime over y. It's ln of 2. Y prime is equal to ln of 2 times y, which is 2 to the x.
You did that all in your head?
Yeah. Just do it in your head.
That's crazy. Okay, thank you.
If you do it like 1,000 times, you can do it in your head.
Okay.
All right, got it. Very beautiful, right? Okay, we're going to show you something more beautiful than this.
Oh no. I've had enough beauty today.
Yeah. I'm already overwhelmed with the
Okay, so we're gonna talk about this special. This is a very cool one. I always love this one. This is like only series I really love. I hate all other series because I don't know how to do them well. But this one, it's okay. It's doable. No, I mean, this is not my favorite one, but this is the coolest one.
That sounds like a really great.
Coolest looking one.
Oh, can you grab it for us that when we finish the problem then?
How much time I have?
6 minutes.
Yeah.
Okay.
Choose one time.
Okay. That means
Ooh, somebody already read out a term. Good job. If this is n equal to 1, it's 1/2 minus 1 what?
1/3.
1/3. Keep on going. You're gonna see something. You're gonna see something. 1 what?
1/3 minus 1/4. 4th minus 1.
Okay, so
Two.
Oh, they cancel.
3, hold on, 3 over 6 minus 1 over 6.
Yo, he's
They
right.
cancel.
Cancels out, so it should 1 over n.
What?
Yeah.
Whoa, that's
So
hold on.
that's why I told you it's kind of cool, right?
yeah.
Plus 1 over 5 minus 1 over 6, right?
Yeah.
Guess what?
Should be 1/2.
Everything cancel out after that if you go to infinite.
So convergence.
The answer is 1/2. They not only converge, it actually converge into a number. It converge into 1/2 because number gets smaller. They kind of subtract each other, but there's a cool name. I love this name. It's called telescope sequence series,
Oh, that's what you said on Friday.
which is natural log of n plus 1. The one on Friday was natural log of n minus natural log of n plus 1, something like that. So they will always subtract each other.
That's
If they subtract each other, your final answer is beautiful. It's 1/2. But what's a prerequisite of telescope series though? Remember, you always have something subtract each other, right? You always have something subtract each other. What if you don't?
too bad.
Make them something subtract each other. Okay? So I'll give you a question and let you think about it. You had to use whatever knowledge you learned before. It's on your prior test and it's on your prior test. You're like, what? What? Okay, so this one.
It's gonna be arctan.
No, you dumb dumb.
It's
Arctan's a
Sine.
plus sign.
Yeah.
It's not sine either. Sine has a square root.
Is secant?
You just missed the best part, Emily. You always miss the best part.
You don't know what telescope.
Which arc is it?
I'm gonna watch the video back.
You always miss the best part.
Yeah.
You always like work it out exactly the wrong time.
We're gonna use a triangle.
It's at the same
Huh?
time every
Triangle.
day.
Don't use the triangle, but it's a good idea, but it's not triangle. Remember, shh, in order to have telescope, you need to become two fractions.
Oh, split the fraction.
Decompose that.
Oh.
Whatever he said, I support that actually.
Decompose and all hypothesis.
I support what she said.
N
That's
plus
what it's
1
called.
minus
We call it null hypothesis the hoe. Because it's h of 0, so we can just say hoe. Yeah.
That's
You don't.
he would have.
No, what about the hoe?
Oh yeah, the ho and the ha. Oh and ha.
Yeah.
Yeah.
What is hot? Alternative hypothesis.
Alternate hypothesis.
Mr. Castle wants to make lots of funny jokes about that. Yeah. What he used to say?
Always use negative language about
Funny,
the
no,
hoe.
never trust the
30
never
times,
trust
I
the ho.
guess. Not the last 100.
Oh, yeah.
Yeah.
Never trust a
No,
hoe.
no, never support the hoe.
I never support a hoe. Okay. Never trust a hoe. It doesn't make
No.
sense.
It's a reject the hoe or
Never
fail to
right.
reject the hoe.
That was it.
Yeah.
The ho's never right.
Reject the hoe.
You reject the hoe or fail to reject the hoe.
Yeah, exactly.
That's actually pretty funny.
Yeah.
Actually, kind of makes sense.
Yeah.
Literally.
It's the language you use on the IP
Oh,
exam as well. Like you just say hoe.
Like class is so easy.
Okay.
Do you know how to decompose this?
Yeah.
I'm sure I could.
One.
It's pretty easy.
B equals
A plus 1 over 2
Alright. How dare you, Andrew?
is yeah. So then you do 2.
A over
Then minus 1
2n plus 1
plus.
plus b.
I don't like decomposing fractions.
Chill.
No, it's like a.
Decompose
So then it's gonna
fraction.
be
Oh no.
n can be a positive. Wait, it's gonna be halves. We're with halves here.
What do you mean halves? The one on the left is
They
2.
cancel out, y'all. They cancel out.
Careful back.
What are you talking? Okay.
They cancel out.
Cancel back. B.
Andrew's way too far ahead.
They cancel out. It's not bad. I'm just saying they cancel out.
Oh, two. They're both two. Well, one of them's.
No, spoiler alert.
Let's talk about sequence first. The sequence is a to the 4n. Oops, 4n squared minus 1. Did anybody decompose this?
Yeah.
2m minus 1 and 2m plus 1. And then what happened? You decompose.
A over 2 over 2 minus 1. B over 2 minus 1.
Did you do this?
Oh, sorry. No, that's. I thought you were talking about A and B.
Okay, so if you plug in, so it's gonna be 1 over 1
No.
minus 1 over 3. And then this is plus 1 over 3 minus 1 over 5. And then plus, what is it?
1 over 5 minus 1 over 7.
1 over 7? So eventually this term is going to go away, away, away. Everything becomes 1. So if it's not a fraction, make it a fraction, and then write out first few terms. You should see the pattern. Once you see the pattern, you can decide